Hello dear student, I am Monir Islam. Today in this video we are going to discuss another 4 question of CSIRNet. Okay, and of chapter Countibility. Okay, so this video will be more useful. Okay, and from tomorrow on we will start the second chapter, that is point set topology. Okay, after that sequences series. So this is the last video of this of the chapter Countibility. Okay, and hope I will discuss all questions of CSIRNet. Okay, till 2011 to 2020 2022 I think. Okay, that I mean asked in CSIRNet. Okay, I will also discuss some 6 questions of countibility of NVH and PhD. Okay, I think there are no questions left. Okay, if you have any doubt, or you can send me that question in WhatsApp. Okay, I will discuss that in the next video. Okay, so today I will discuss the remaining 4 questions, and from tomorrow on I will go to the next chapter. Okay, so we are doing what I will doing chapter is question discussion of real analysis. Okay, after that I will start after finishing the real analysis I will start the linear algebra. Okay, so linear algebra PYQS discussion. So let's start. So this question from June is asking, that question asked in 26 November 2020. Okay, so let's see this question. This question asked in 26 November. CSIRNet 26 November 2020. Okay. This is part C question. Okay. So read thoroughly the question. Which the following sets are biased with R? Okay. We know two set A and B. Suppose we have two set. Okay. May have coordinate finite or infinite. Okay. If suppose A be a biased between two set, be biased between two set, then if you leave coordinate of A, this will be coordinate of B. Okay. If two set is biased, then both set have same coordinate. Okay. If in two set there is bias, then both set have same coordinate. If this set have same coordinate, then between there is bias. Okay. So see, so which of the following set are biased with R? Okay, there are option 1, 2, 3, and 4. 4 option given. So see what is the coordinate of this set. Okay, first you have to understand what is this set. I am naming it S1. S1 is nothing but nothing but settable map. Those hopefully you know this mapping. I have discussed in previous video. So settable map, that map F from 2 point set 0 on to n set n. Okay, so what is the coordinate of this set? S1. If it mapping from A to B, it is A and it is B. I have discussed the coordinate of A, the settable function from A to B, nothing but coordinate of B per coordinate. Means coordinate of natural number and coordinate of this set 0, 1. Okay. Now coordinate of natural number is, you can say alif naught, and coordinate of 0, 1 is 2. Okay. Now alif naught per finite number is gives again alif naught. So this set is this is coordinate is alif naught. Now if it bijective, suppose if A be a bijective from S1, this set with this set to R. Okay, then this is if it bijective mapping, suppose it is bijective, then this will imply coordinate of S1 will be coordinate of R. Okay, but coordinate of S1 will be alif naught and coordinate R will be continuum. And continuum is always greater than alif naught. So this is a contraction, na? So this is a contraction. Okay, this is a contraction. Hope you understand, this is contraction. So this set never has bias with R. Okay. Now see, going to the option 2. So option 1 is incorrect. Okay. This set is never given bias with R. Now this is set will map from n to 0, 1. Okay. You can name it S2. Name it S2. If you name it S2, this S2 is nothing but settable map from n to 0, 1. Okay. Then what is the coordinate of this set? Then coordinate of this S2 will be coordinate B. This is A, this is B. Coordinate B means 2. Coordinate natural number is alif naught. So 2 per alif naught will be n continuum. N continuum nothing but coordinate of R. Okay. So you can say there is a bias on F from S to R. That may be such that F is bijective. Okay. So option 2 is correct. Now settable subset of n. This is bijective with R. If you check the cardinality, okay. What is the cardinality of settable subset of R? Set of all subset of n. Okay, this is nothing but, you can say, this set belongs to this set such that those are subset of n. Okay, this is nothing but power set of n. Now what is the cardinality of this set? Power set of subset of n. If you want to compute its cardinality, then what is cardinality of this? Cardinality of this power set of n. And power set of cardinality will be nothing but cardinality of this set. Okay, now cardinality of natural number alpha naught, 2 power alpha naught is C, is quantum. Okay, it's quantum, and quantum is nothing but cardinality of R. So both settable subset of n and R have same cardinality. So the similar expansion, option you can say there is a map G from, if you name this set S2, say there is a map G from S2 to R such that G is bijective. Okay, so this map is bijective. From there S2 to R there is a bijective map. So you can say both sets are bijective. There is set are equivalent. Means both sets have same cardinality. So there is this set of bijective with R, this set of bijective with R. Now settable subset of R. Does it have bijective with R? What is settable subset of R? Cardinality. So you have to compute the cardinality of settable subset of R. Means settable subset of all subset of R with cardinality. Settable subset of R means it's going to say B. Those B belongs to the set that has the B subset of R. Okay, it's nothing but power set of R. Okay, so cardinality of power set of R, nothing but cardinality of R. Okay, because it is real, na. Cardinality of power set of A for any set A, cardinality of power set of A for any set A will be nothing but 2 power cardinality of A. Okay, for any set A, subset R you can say. For any set A, cardinality of power set of A, nothing but 2 power cardinality of A. So cardinality of R will be continuum. So this is 2 power continuum. Now 2 power continuum is always greater than C, na. 2 power C is always greater than C, and C is cardinality of R. So power set of R cardinality is greater than cardinality of R. It's not equal. So you can say from here cardinality of power set of R is not equal cardinality of R. Okay. So in between power set of R there is no bijection. Okay. So settable subset of R with R have no bijection. So you can say this option is incorrect. Okay. So in this question correct option are option 2 and option is 3, right? 3. Option 2 and 3 are correct option. Okay. And option 4 is incorrect. So in this question correct option are option 2 and 3. Okay, hope you understand the solution. If you any doubt, you can always ask in the comment section. Okay, so we're going to next question. This question asked in December, CSIRNET December 2019. Okay, December 2019. This is part B question. Means 3 marks. Okay, this is the set. Which is the following set are countable? Okay, so set up first of all. So we are going to start from option 1. Settable function from Q to Q is nothing. If you name it S1, this set, then this thing nothing but this set is nothing but same with this. Settable function from Q to Q. Those set belongs to function. Those functions will set. Those are making from Q to Q. So what is cardinality of S1? Nothing but cardinality of B is cardinality of A. If you name it B, cardinality of B means cardinality of Q or cardinality of Q. Now Q to cardinality of Q can't set cardinality is alpha naught. Alpha power alpha naught is it will be 2 power alpha naught, because you know the result. If alpha or beta are cardinal, then the alpha to beta will be equal to 2 to the beta if alpha less equal to beta. Okay, if you apply this here, so you get alpha power alpha naught, so 2 power alpha naught. Now 2 power alpha naught is continuum, na. The continuum is uncountable, so this set is uncountable. This is incorrect. Now settable function from Q to 0 on. Okay, option 2. Settable, name it S2. Set contain those function from Q to 0 on. Settable function from Q to 0 on. Okay, name it A, name it B. Then cardinality of S2 is nothing but cardinality of B means 2 points. Cardinality is 2, na. So 2, and cardinality of Q is alpha naught. 2 power alpha naught. 2 power alpha naught is continuum again. So this set cardinality is uncountable because its cardinality is continuum. C means continuum. So continuum is cardinality of uncountable set. Okay, so S2 is uncountable, na. So S2 is uncountable. So it is not countable. So option 3 is correct. Now settable function, I have just proved this in the previous question. Settable power set of n, its cardinality will be 2 power n, and 2 power n is alpha naught, and 2 power n is continuum. Continuum is uncountable, so this set is cardinality uncountable. So it is cardinality continuum, so it is uncountable set, so it is incorrect. Okay, so option 3 is right. And this option I have discussed in the previous video. Okay, the settable function Q to 0 on with outside finite set. is countable set. Okay, this is countable set. I have discussed in the previous video of envisioning PhD question. In envisioning PhD question, I have discussed that. Okay, I am giving that hints that this is nothing but if you name it S3 settle function f from Q to 0, if it settle function from Q to 0, then it is uncountable. But it's saying not saying only this. There is restriction. So those functions used to set which are vanishing outside the set. As you can say, f is unitarily 0 outside a finite set a equal to x1, x2, xn. Okay, you can say and the values of f at x1 is non-zero, fx2 is non-zero, and you can say fxn are non-zero, but outside this set all values are 0. So range of, you can say range of f is countable na. Range of f, you can say from here range of f will be a countable set. Okay, so now if you take an union of all f such f, then give to total set S. Okay, so so this set become countable. In this way this set become countable. Okay, we understand this because it is only two value, only n values are non-zero na, outside values are 0, so this set is countable na. So this is countable. So in this question option 3 are correct. Okay, so in this question option 3 are correct. So we understand. If you find out, you can always ask in the comment section. Okay, so I discussed 2 questions. Now we are going for a part B type question. This question asked in CSIRNet. This question of I think in June 2018. Okay, part B type question. B type question, 3 mark question. A is equal to xy, those order of to set such as x square plus y square 1 equal to 1 minus square, where any natural number xy are from coming from rational number. Okay, xy coming from rational number set. Then which of the following set are true? Okay, not see this. There are proofs and given. Okay, so first of all, I am taking a member from the set xy. Okay, arbitrary. If I take any arbitrary member from the set, let xy belongs to S, be arbitrary. Okay, so xy must satisfy this equation x square plus y square equal to n square na, by n belongs to natural number. You can say and x is coming from rational number, y is rational number. Okay, so from here you can write y square equal to 1 upon n square minus x square. Okay, so from here you can write y equal to plus minus root under 1 upon n square minus x square. Okay, so this set become, so S, if you name it the set S, or if you name it the set S, then you can from here you can write y equal to plus minus root under 1 minus x square. Also if from this expression you can get another expression. You can write x na, x in terms of y, this will be plus minus root under 1 upon n square minus x square. Okay, this is also possible because from here you can write y in terms of x, or you can write x in terms of y. This is y 1 upon n square minus y plus minus root under 1 upon n square minus y square. Okay, so you get S is nothing but union of 2 set. Okay, you can write S is union of 2 set. Okay, S is union of 2 set actually. And S1 is equal to plus this is x 1 upon n square minus y square. This is y. Okay, where y belongs to rational and n belongs to natural number. And S2 is nothing but this is x and plus minus number 1 upon n square minus x square, you can say. Okay, and you can say x belongs to rational and n belongs to natural number. Okay, now see y belongs to rational number, n belongs to natural number. Okay, so you can say this order pair will be totally rational number na. This rational number, y is also a rational number. Okay, for any value of n, this will be a rational number. Y is rational number and y is rational number and this is rational number and n is a natural number. Okay, so this is rational number 1 upon n square minus root under 1 upon n square minus y square. Okay, so this set S1 equal to plus minus 1 square, this is countable set. Okay, How? Because if it counts, you can count this set in terms of n. Okay. Also similarly, this set is also countable. Okay, because you can count this set in terms of n. Okay, you put n here, you get a set. If you put n equal 2 here, you get another set, another member of the set element. You put n equal 3 here, you get another member of the element. If you put n equal 3, I'm suppose putting n equal 1, then you get this element x plus 1 minus x square. Okay, this element. You put n equal 2 here, you get another element. You get sequentially. Okay, 1.4 minus x square. Okay, like this. So on pattern. For every single number, you get an element now. So you can count this. Okay. So S2 is also countable. So similarly, this is also countable. This set countable. This set is countable. Now this countable union na. So countable union of countable set is countable. You can say. Okay. So S will be countable. Okay. So this set will be countable. So this set will be countable, not uncountable. In finite nodes, no, it's countable. Okay. This empty to no. So this is countable. So this is option 2 is correct. This question. Okay, hope you understand my solution. Now we are going to last question. This is the last question, okay, of this video, and I will close this chapter with this question. Okay, so this question asked in CSIRNET June 2018. Okay, this is part B question. In part with 3 mark question. Okay, given ABCD are real constant, where ABCD are real constant such that the identity hold this. Hold, and for example start, then asking what is the values of lambda. Okay, lambda minus 5, lambda greater than equal to 1, and 0 lambda, no such lambda is. Okay, so first try to understand this identity. ABCD are real constant, means ABCD, you can ABCD belongs to R. Okay, so this identity given lambda square 2xy y square ax plus bi whole square cx plus dy whole square. This okay. So from here you can write lambda square plus 2xy plus y square. Break this, you get a square x square 2ab xy. Okay, b square y square. Okay, from here you get c square x square 2cxy plus d square y square. Right, now if I apply lambda square x square 2xy y square. Okay, from here you can write if take common x square, the x square or c square. If you take out the common x square, then it gives a square plus c square s square. Now take out the common 2xy, 2 then it will be ab 2ab, I think this is cd. Okay, 2 cd, because cd na, if you multiply then 2 cd xy, 2 cd outside will be xy. It gives b square plus d square y square. Now this identity na, this is identity for xy, so this is also identity for xy na. Is given this identity this identity hold for xy belongs to R. So you can compare the coefficient of x square, 2xy and y square. So comparing the coefficient, so if you comparing the coefficient of x square, xy and y square, we get what we get. See, if you compare the coefficient of x square, you get here a plus c square, and this is lambda. So a square plus c square, this will be lambda. Okay, equal to number 1. And also coefficient of xy, if you get the coefficient from, you get 2ab plus cd, and this is 2, means gives ab plus cd equal to 1. This is number 2. In coefficient of y square will be b square plus d square, and this is 1. Okay, so we get b square plus d square, this gives 1, number 3. Okay, so see there are 3 equations, 1 equation, this second equation, this third equation. There are 3 equations and 4 unknown, a b c d. There are, hope you understand, there are 3 equations, okay, with 4 unknown. Means number of equation is less than number of unknown. Okay, number of equation you can say m less than number of unknown. You can number of equation r, number of equation you can say number of unknown is m. Say 10. So it has three equation, 1 2 3 equation, and there are 4 unknown ABCD. Okay, so this equation has infinite solution, you can say, because there are number of equation less than number unknown. So in this case this have not any solution, it have infinite solution. So you have to fix the value. Okay, so I am fixing a value. You have to fix a value na, so I am fixing a value. So either you can fix either C or D to be a value. Okay, so I am fixing a value. See, I am fixing C equal to 0. I'm fixing this value C equal to 0. So if I'm fixing C equal to 0, from here you can see this is 0. Okay, so this equation gives AB equal to 1. AB equal to 1 na. AB is real constant and this gives AB equal to 1. Okay, so you can take the case that A is 1, B is 1. This is the case na, case 1. This may be a case A equal to 1, B equal to 1. Take this value. Then if A equal to 1, from here you put that A equal to 1 in this equation 1, put A equal to 1. So this is 1 plus C square equal to lambda na. This is 1 plus C square lambda. Okay, so you can say from here you get 1 plus C square lambda. From 1 you get, if you put A equal to 1, then you get 1 plus C square equal to lambda. Okay, now this will be lambda minus 1 equal to gives C square. Okay, now C square always greater 0 for any real constant. So from you get lambda is equal to 1. Okay, so using the value of A equal to 1, B equal to this real constant, C equal to 1, and C equal to 0, and D it put C equal to 0, and then you get the values. And D may be any real constant. I think B is 1. If B is 1, if you can put B equal to 1 here, so this is D equal to 0 na. So A equal to 1, B equal to 1, C equal to 0, and D equal to 0. Use this constant. If you use this constant, then with this identity it gives lambda equal to 1. Okay, given real constant and this identity, this is lambda equal to 1. Okay, so this option is discarded, this also is discarded, this also is discarded. So lambda equal to 1, this option correct. So in this question option 2 is correct. Okay, hope you understand my solution. Okay, if you any doubt you can always ask in the comment section. And with this question I have completed the solution of chapter Countibility of PYQS question. Okay, in the next video we'll discuss the question of point set topology. Okay, I'm going to chapter by chapter. So don't worry, please follow my channel and subscribe my channel. Hopefully you will get everything else. Okay, so if you any doubt you can always ask in the comment section. Okay, so thank you.